Varactor diodes are semiconductor PN junction devices. These are also known as varicaps or voltacaps. For their functioning, they require reverse bias. The main feature of these devices is that they exhibit voltage dependent capacitance. Diodes exhibit capacitance both in forward direction and also in reverse biased direction. Under forward biased condition, the capacitance they exhibit is called diffusion capacitance. The capacitance they exhibit under reverse biased condition is called transition capacitance. Transition capacitance has an important feature. Its value depends upon the bias voltage. More the bias voltage, lesser is the transition capacitance. This feature finds use in several applications like in tuning circuits, in the design of VCOs, etc. This diode also finds applications in the design of parametric amplifiers, which are low noise, high frequency amplifiers. Special diodes, Varactor diodes, series on semiconductor devices and circuits, lecture number 2.22. Varactor diodes are semiconductor diodes. These are PN junction semiconductor diodes. They belong to the category of special diodes. They are used for their voltage variable or voltage dependent transition capacitance. They find applications in tuning circuits and also in the design of low noise, high frequency, radio frequency amplifiers like parametric amplifiers. In the present session, we focus on the basic principle of functioning of Varactor diodes, materials suitable for them, different applications they have. All those things are touched upon here. Let us move further to start the core session. We begin the session with a few introductory remarks. The name Varactor is a small form of variable reactor. These are also known as tuning diodes, varicaps, voltacaps. These are all different names: Varactor diodes, tuning diodes, variable capacitors, voltage variable capacitors, but widely they are known as Varactor diodes. They are designed to provide voltage controlled capacitance when operated under reverse bias. We all know under reverse bias the diode possesses certain capacitance. It is called transition capacitance. This capacitance depends upon the voltage, reverse biased voltage. So it is voltage dependent capacitance or voltage controlled capacitance. This property, it is used for benefit in several applications. The voltage variable nature of depletion capacitance is exploited for the benefit of Varactor diodes. In Varactor diodes, these are developed by Pacific Semiconductors in 1961 and are trademarked as Varicaps in 67. Symbol is given in A. Ordinary diode symbol is combined with variable capacitor symbol. After combining, the resultant one is named as a symbol for Varactor diodes. This is capacitance, this is variable capacitance. In B is shown equivalent circuit. CT is the capacitance provided by the diode under reverse biased condition. It is a variable, that is why this arrow indicates a variable nature of the capacitance. RR is diode resistance under reverse biased condition. It is supposed to be infinity, but in nature infinity is not achievable. It doesn't exist. In practice, under reverse bias, the diode is not open circuit, but it acts as a very high resistor. That resistance is RR. For most of the cases, RR can be, its pressures can be ignored. RS is series resistance of the diode. It may be resistance of the leads, it may be resistance of P slice, it may be resistance of N slice. All those things are included in RS. So this is equivalent circuit of Varactor diode. In C is shown variation of capacitance with reverse voltage. As the voltage increases, you can see the capacitance is falling. We introduce now a parameter. It is called grading quotient. It is an important quotient pertaining to Varactor diodes. The depletion region capacitance CT depends on reverse bias voltage VR, and this relation can be expressed in the form of a formula. CT, transition capacitance, it depends upon VR, reverse bias voltage. The dependence is given by K by Vt plus Vr power n. Small n is there. What is K in this formula? K is a material and construction dependent constant. Vt is also another constant. It is called built-in knee voltage. N, what is N? N is called grading quotient. It is an important one, its value being dependent on doping profile. Its value is half for abrupt step junctions, 1/3 for linearly graded junctions. What are abrupt step junctions? Diode means p-type of impurities on one side and type on the other side. Let us suppose p-type impurity concentration is uniform on p side. Impurity concentration n side is also uniform. Both sides it is uniform, need not be same, but uniform. With this type of impurity addition, one can fabricate a diode. Such a diode is called abrupt step junction diode. Another type of impurity addition is there. In this case, impurity concentration addition, it is made such that impurity concentration increases from junction towards the end like this in a linear manner. P side as well as N side too, it increases. They need not be having same rise, but they rise linearly. Junction with such type of impurity addition, they are called linearly graded junction. For them, N value is 1/3. Some more points. It's also possible to express diode capacitance in terms of zero bias capacitance, CT of 0 as CT of VR is equal to CT of 0 by 1 plus mod VR by VT whole power n. Either one can be used. The capacitance varies with the temperature, and this dependence is quantified with the temperature quotient TCC in percentage per degree centigrade. These are units defined as TC function of VR equal to delta C by C naught delta T into 100. Here, delta C is the change in capacitance from its initial value C naught due to temperature change delta T with its initial value T naught for a reference reverse bias voltage. As already mentioned, grading quotient is an important parameter pertaining to Varactor diodes. Some points here are being given to explain its importance. Grading quotient N is a critical parameter indicating the performance of the diodes. It is related to diodes doping profile, which can be expressed as K x power m. Here K is a constant, x is distance from junction, and m is another constant, assuming zero value for abrupt junction diodes, 1 for linearly graded junction. N and M, values of N and M are related through N is equal to 1 by M plus 2. So grading quotient essentially, it depends upon doping profile. So capacitance variation with voltage depends upon doping profile. To achieve larger variation in capacitance than given by ordinary types, a class of diodes known as hyperabrupt junction Varactor diodes are designed. In these diodes, one side of the junction is heavily doped to increase zero bias depletion capacitance, and on the other side, the dopant concentration is made to vary with the distance from the junction. Basic point here that is being mentioned is hyper abrupt junctions. Hyper abrupt diodes are an important class of Varactor diodes. A sophisticated, versatile Varactor diodes. Here M assumes negative values, usually 1 among -1, -3 by 2 or -5 by 3. The corresponding values of N then are 1, 2, 3. It can be noticed N is assuming larger values for hyper-abrupt junctions. Grading quotient is large for hyper-abrupt junctions. Applications. The advantages of these diodes include smaller in size, light in weight, very light in weight, higher levels of reliability, absence of moving parts, broader bandwidth, fast response, and even remote tuning possibility. These diodes are widely used in electronic tuning systems like in TV sets, domestic TV sets, in radars, etc. When used in electronic tuning systems, they eliminate the necessity for moving parts. These diodes are less noisy and costs less when compared to other conventional diodes. Varactor diodes are mainly used as voltage controlled capacitors. Capacitors whose capacitance depends upon the voltage. They find application in the design of voltage controlled oscillators, VCOs, parametric amplifiers, frequency multipliers. VCOs find several applications such as frequency modulation for FM transmitters and phase locked loops, PLLs, etc. For the frequency synthesizers that tune many radios, television sets, and cellular telephones, PLLs are used. So tuners, varactors are well known for tuning electronic receivers. radio receivers. They are also used in radio receivers and self-balancing bridge circuit. In applications like harmonic multiplication, a large amplitude AC voltage is applied across a varicap to generate higher harmonics, which are extracted through filtering. What is this harmonic multiplication? It is a way by which one can generate higher frequencies, harmonic frequencies. Varicaps, they are used for generating higher harmonics also. When a sine wave current of sufficient amplitude is applied, the resultant voltage gets peaked into a more triangular shape and odd harmonics are generated. This slide is about an application of varicaps for obtaining higher harmonic frequencies. Now we consider a few points regarding specifications of Varactor diodes. Their specification includes reverse current or leakage current IR, the current at a specified reverse voltage. This is one specification. Reverse current or leakage current. Capacitance ratio, CT minimum by CT max. Ratio of minimum capacitance to maximum capacitance. Smaller ratios indicating larger ranges of capacitance. Terminal capacitance or diode capacitance. This is another specification, CT. The minimum capacitance when the specified reverse voltage and frequency are applied. Another specification is junction operating temperature, TJ. The range of temperatures at which diodes are designed to operate. Power dissipation, PD, measured in watts. The maximum power dissipated by the diode while it is on state at a specified ambient temperature. The reverse current or leakage current, capacitance ratio, terminal capacitance or diode capacitance, junction operating temperature, power dissipation. These are main or important specifications of these diodes. Some more on specification. The IC package types in which Varactor diodes are available include PO. PO stands for transistor outline. DO, diode outline. SOT, small outline transistor, and SOD, small outline diode. These are various types of IC packages pertaining to Varactor diodes. They are also offered in a discrete package, DPAK, in D2PAK, a large surface mounted package that includes a heat sink. These are IC package specifications or IC package types. With this, we come to the end of this session. Before closing down, let us recollect important points that are discussed in the present session. Important features of Varactor diodes, they are discussed. Their applications. Important terms like grading quotient, hyper abrupt junction. They are also introduced. and described. Hope this session is useful to you. We meet again soon in another session with a new topic.